right, next section in your notes as we begin our material for test 2, which obviously won't be for a few more weeks. Next topic we want to talk about is angles on the Cartesian plane. We're going to do quite a bit with graphing this year, and so we're going to take a geometry concept like an angle, which again could be a trig concept if it's in a triangle, but we're going to put it on the Cartesian plane. Angles on the Cartesian plane. First thing that we need to get down with our angle is that every angle has a certain type of rotation, right? Typically we think of the angle maybe rotating like this. Well, for an angle, whatever side begins the rotation, starts the rotation, is called the initial side. The initial side, right? We're familiar with the term initial. I actually use this word quite often. For instance, if there's an answer that, reduces or changes, say, what did you get initially? Okay, what was your final answer? We're familiar just with our initials, right, EJ? Yeah, it's the thing that begins each of your names, right? So, I'd be RN, right? Those are my initials. Well, where does the term initials come from? It's the thing that starts the name. So the initial side is the side that starts the angle. The side that ends the angle, or the side where the angle ends, is called the terminal side. The terminal side. Terminal has this idea of ending, that which ends, right? A terminal illness is one that would end someone's life. For many, coronavirus, or one of the complications from that. That's been the case here recently. Terminal degree in college is the highest degree you can get. So for most people, that would be a doctorate. For people in the performing arts, the MFA, Master of Fine Arts, is their terminal degree. It's the highest that it gets. In business, I believe it's the MBA, the Master of Business Administration, is that highest degree someone can get, a terminal degree. It's the end of it. It's the end of the line. There's nowhere else to go. So the end of the angle is the terminal side. When we draw angles on the Cartesian plane, though, we need to draw them in what's called standard position. Standard position. Couple requirements for standard position. First of all, the vertex of the angle must be on the origin. The vertex must be at the origin. Second, the initial side must be along the positive x-axis. The initial side must be on the positive x-axis. So when angles are drawn on the Cartesian plane, we don't just draw the angle however, wherever, but specifically on our axes, we'll put the vertex here at the origin. The initial side will be along the positive x-axis. Now the terminal side will be wherever, right? Like if it's an acute angle class, then the terminal side is going to fall here in quadrant 1, right? If it's an obtuse angle, well, now the terminal side will fall in quadrant 2. And if an angle goes all the way around to quadrant 3 or even quadrant 4, we have something called a reflex angle. Technically, acute and obtuse angles are also oblique angles. That's a good term there. But yeah, so the terminal side just falls wherever. We refer to the quadrant of an angle as the quadrant in which the terminal side comes to rest. The quadrant of an angle is simply the quadrant in which the terminal side comes to rest, or what the terminal side is. Where is it at? Okay, that's what quadrant. So then, quadrant 1 angles are acute. You can call them quadrant 1 angles. Quadrant 2 angles obtuse. Quadrant 3 and quadrant 4 angles are reflex angles. Now, it is possible to have an angle that doesn't lie in a quadrant, right? You think of an angle that would not lie in a quadrant? 90-degree angle, right? If it's on an axis, so a 90-degree angle would not actually be in a quadrant. It's right between quadrants 1 and 2. Also, 180 degrees, right? That's right between quadrants 2 and 3. 90 degrees more would be a 270-degree reflex angle, right? That's not in a quadrant. It's between 3 and 4. 360 degrees, right? A paragon falls right between quadrant 4 and 1. I mean, a complete revolution there with the paragon. Angles that don't actually lie in a quadrant have a special name. They're called quadrantal angles, or quadrantals for short. quadrantals. Something refers to an angle that doesn't have a quadrant. It's homeless. Now, typically when we draw an angle, we're used to having the initial side here and our rotation going counterclockwise. It's just how we draw angles. But you know from geometry, right, you could have an angle that goes this way. It's just weird to draw it that way. We don't normally do that. So typically, a clockwise rotation is considered a positive angle. A positive angle is one that has clockwise rotation. Clockwise rotation. And that's everything that I drew just a moment ago. Everything was assumed to be coming clockwise off of the initial side, right? But it is possible, I suppose, that starting here at the positive x-axis with my vertex at the origin, I could rotate downward, backward, if you will, counterclockwise rotation. And this is a negative angle. Negative angles rotate clockwise. Negative angles rotate clockwise, again from standard position, whereas a positive angle would go upward counterclockwise. So positive angle goes this way, negative angle goes that way. So then, if we consider for a moment a quadrant 3 angle, use the yellow chalk for a little bit of contrast. Not sure how well it'll show up on camera, but you guys in the room should be able to see it fairly well. A quadrant 3 angle, if it's a positive angle, would be a reflex angle, wouldn't it? But if it was going the other direction, if all you saw were these two lines, you don't know, it could have gone negative, in which case the negative angle would simply be an obtuse angle. Now, typically, we assume positive rotation unless otherwise specified, but technically, this same terminal side could reflect a positive reflex or a negative obtuse, right? Now, are these two angles equal to each other? No, right? No. But, for instance, if this is, let's just say, positive 200 degrees, how big would this angle be? Together, they make a full 360, don't they? So then it'd have to be negative 160, wouldn't it? And they share this ending side. These two angles are called coterminal angles. Coterminal angles refer to angles which share a terminal side, which doesn't mean they're equal, by the way. Could they be? Well, sure, 200 and another 200 are coterminal, I suppose, coincident. But 200 and negative 160 are also coterminal angles, aren't they? What if, put our initial side down here, vertex at the origin, and we rotate all the way around, and we just keep going to here. Positive rotation, right? All the way around 360, and then another 200. How big is that angle? 560 degrees. That's also coterminal with those other two. What if I 1, 2, 3, 4, 5, 6, and 200? Let me have to do 6 times 360, there's a 2,160, plus 200 is a 2,360 degree angle. Is also coterminal. You get the idea, there's really a limitless number of coterminal angles because we're not restricted to only 360 degrees. Angles could spin all the way around and keep on going, couldn't they? Questions on coterminal angles. We're going to come back to them in just a little bit. Turn your books to page 35 now. Page 35. We're going to practice drawing some angles. Graph paper's recommended here, though we're not going to draw really fancy Cartesian planes for this exercise. We're just going to draw quick sketch graphs, which really just means draw your axes. Technically, I suppose you could do this without graph paper for now, but graph paper, again, we're going to be using it here a little bit anyway, so might as well use it here. Number one, they want us to draw, to the best of our ability, a 30-degree angle in standard position. So, draw your axes. plot your vertex, if you will. Maybe darken that initial side just a little bit. And then to the best of your ability, draw what appears to be a 30-degree angle. Now remember, what you want to theoretically have is 1/3 of a 90-degree angle, correct? So you don't want to go halfway, you want to go less than half. So as if we were trying to get 3 equal angles up here. Approximately a 30-degree angle. The good news is, from geometry, we don't trust our eyes anyway. So if we say it's a 30, that must be a 30, okay? But do make it look somewhat close. Okay, the question is, and the book instructs us here on number 1, go ahead and draw the identifying arc as well. That means this little arrowy thing showing the progression of opening, that positive 30-degree angle. It says to identify the initial side. I'm just going to put an I here in the terminal side. I'll just put a little T here to mark the initial and terminal sides. And it says identify the quadrant of the angle. Well, obviously, class, this is a quadrant 1 angle. Make sense? That's all we're doing there. Say so number 3, do the same thing, but this time with a 200-degree angle. Conveniently, I did a 200 just a few moments ago. So we should have a pretty good idea of what to make it look like. I'm going to draw a 200-degree angle. So we'll start with the initial side. Where does the terminal side end up, class? Quadrant 3, just barely into quadrant 3 though, right? Just about 20 degrees past. So there's my identifying arc, there's my 200-degree angle, there's the terminal side, and of course it is a quadrant 3 angle. Do we have something that looks like this? All right, number 5, a negative 15-degree angle. A negative 15-degree angle. Initial side. And for a negative 15-degree angle, class, I'm going to have to rotate clockwise. I'm going to have to start by going down, but not much, right? 15 is barely anything at all. So just this little tiny arc here for my negative 15-degree angle to the terminal side. And of course, this is a quadrant 4 angle, right? How many had something that looked like this? Good, go on to number 7, a negative 215-degree angle. A negative 215-degree angle. To rotate clockwise here. So as I rotate, negative 90, negative 180, I need to go 35 more degrees, which is going to wind me up here for my negative 215-degree angle. You should have one in quadrant 2. Just get an angle like this. Right? Questions on that, Jamie? All right, so again, going negative 90, negative 180, and then we need 35 more negative degrees rotating past. How about number 9? A negative 135-degree angle. A negative 135-degree angle. I didn't do a very good job of this, I don't think. We should be shooting for the bisector of the 3rd quadrant here, shouldn't we? We've got 90, we need exactly 45 more. Hey, I did a really lousy job on the bisector there, so it should have come out looking a little bit more like that maybe. Something like that. Okay? Now the nice thing is if you're using your graph grid, right, what you'll do is you'll use these lines on the paper and you'll try to hit these corners to get a perfect 135 or negative 135. Use those vertices of the squares on the grid. All right, number 11, a 235-degree angle. Number 11, a 235-degree angle. Obviously, we're going to start here on our initial side, 90, 180. Let's see, this would be 270. I can't go that far, right? Where is 235 closer? Is 235 closer to 180 or 270? It might be slightly closer to 270. In fact, if you were to figure 45 more, that's 225. So if this is the bisector, I need to go just 10 degrees past the bisector, which is barely anything at all. Again, if you want to get a really accurate drawing, so there's the initial side, the terminal side, there's my 235 degrees, which of course is in quadrant 3. Feel like we got the handle on this? All right, what I'm going to do is skip the terminal and the initial marks, but still draw the angle itself and mark it. I want you to do the evens now, 2 through 12. Without using a protractor, try to be as close to exact as you can be. 2 through 12 to even now. And we're going to be doing a lot with angles in the days ahead. We want to make sure we've got a good understanding of what they look like so we can visualize them as they come up. about 30 seconds longer to finish your sketches. Glue these together. All right. Number 2. What quadrant does 15 degrees fall into, class?
1.
Quadrant 1. Just barely anything here in quadrant 1 for our angle. Number 4. Negative 120, class, falls into quadrant 3. It's going to rotate backward about 30 degrees past the 90, and there's your angle there. For number 6, negative 25, class. Quadrant 4, down about, not quite to the 30, so maybe that's a little too negative of an angle. Maybe something more like that, perhaps. Number 8, 115 degrees, class. Quadrant 2. So there's the 90, about 25 past, something like that for our angle for number 8. Number 10, negative 270. It's a quadrantal, and it's going to fall where usually the 90 would be. So there's our angle for negative 270. What about 165? Quadrant 2, almost to the 180, but not quite. Okay? How many had all 6 angles drawn correctly? All right? Questions on this? All right, next thing in your notes, finding coterminal angles. And Quentin, you seem to have got this really good already because you were answering all the coterminal angles. I hadn't even taught it yet. There is a formula you can use. I don't normally use the formula too much myself because really it's more of a concept than a formula. But we had earlier, I think it was a 200 degree angle. And Quentin noticed that 200 positively and negative 160 would meet up to complete the 360, right? So he said that negative 160 was coterminal. But I also said, what if you went around a full 360 and then the next 200 as well? He said, well, 560 would be coterminal as well. Really, all he did to go from here to here, class, was add 360. And technically, all he did to go from here to here is subtract 360. What we call the coterminal angle rule, it's a fancy name. It basically just means add or subtract 360. The coterminal angle rule is this: theta plus or minus 360. There you go. Now, you may do it multiple times. Okay, you may add 360 multiple times or subtract 360 multiple times. But that's really all you're doing is adding or subtracting 360 to find a coterminal angle. Now, if you wanted to find lots of coterminal angles, your calculator has a feature that I think Chris was actually asking about the other day. If you look above your hype key, which by the way does not find a hypotenuse, if you look above the hype key, you'll see the letter K. Now, Ethan, yours may not have this feature, but you know how a cheapo calculator, if you do like 3 plus 3 equals, how many did that as a kid? You kept hitting the equal button and watch the numbers go up. We'll do that on your calculator. 3 plus 3 equals. Wait a second. Scientific calculators are made to prevent mistakes, like accidentally hitting equal sign twice. Once a calculation's done, it doesn't matter how many times you hit equals, it's not going to keep calculating it, unless you put on the K feature. So do 3 plus 3, but before you hit equals, second function K. Now you'll notice a little K pops up in the corner. Now it equals. The K means constant. You're going to constantly do this function. Well, imagine doing this with a 200 degree angle. 200 plus 360, second function K, equals, there's a coterminal angle, equals, there's a coterminal angle, equals. Oh, by the way, there was my 2,360 we had a minute ago. And if you just keep hitting equals, you keep getting coterminal angles. You can do the same with subtraction. 200 minus 360, second function K, equals, and you get a whole string of coterminal angles. Now, we don't normally need a whole bunch of coterminal angles. So how often are you actually going to use the K? Probably never. But it's just cool to know, right? So Ethan, if your calculator doesn't have that K feature, it doesn't matter because we're never really going to use it anyway. But I just wanted to point out what it did, and I had told Chris that we would learn how to do that, and I don't see...
What I was just doing was I added like I had 360
plus 360 and plus equal and then plus 360 again.
Yeah, you just keep doing another
Yeah.
plus 360. It's not as quick maybe, but it works. Yeah, you don't need to have the K in there necessarily to do it, especially since if I wanted like a string of 10 coterminal angles, yeah, the K feature is nice. But if I'm only asking for 2 or 3 coterminal angles, it's not worth taking the time to put in the K
If I have
probably.
the answer plus 360 and click equal, and I keep doing it.
Oh, so answer plus 360 kind of gets you to the same point
Yes.
as the K value. Okay, all right, that works well. So we figured, see, that's the key, figure out your calculator. All right, so look at the example problem. It says find one positive and one negative angle coterminal with 45. Well, if we want a positive angle, we need to add 360. So notice they added 360, they got 405. Then they subtracted 360, you get a negative angle that's coterminal. They got negative 315. Then they did the same thing with negative 210. You add 360, 150. Subtract 360, negative 570. Questions? All right? Now, what they did on the example is a little different from what they're asking us to do, though, in 13 through 24. Look at the instructions for 13. Read them for us, Quentin.
Find all positive and negative angles between negative 120 degrees and 720 degrees.
That's it. Negative 720 and 720. So basically this. All the angles that are coterminal between 2 full revolutions and negative 2 full revolutions. So let's take a look at a 30-degree angle. Let's first of all add 360 to get coterminal angles. Well, if we add 360, class, we get 390. Add 360 again, what do we get? 750. That's bigger than 720 though, right? They wanted everything in a range of negative 720 to 720. And 750 falls outside that range. Okay, so we're not going to include 750. Go with the 360, subtract, or 330, go subtract 360.
330.
Negative 330. Subtract 360 again.
Negative 690.
All right, if we subtracted 360 again, would we fall too small?
Yeah.
Yeah, we'd be outside the range of the negative 720. So here are 1, 2, 3 coterminal angles. Now, because they want 2 full revolutions and negative 2 full revolutions, you'll wind up with 2 angles that are positive, 2 angles that are negative. Since I was given a positive, there's only one more positive I can get, and 2 negatives. If I'd been given a negative, I would find 1 more negative and 2 positives. Make sense? Do numbers 15 through 23 the odd. Finding all the coterminal angles within 2 revolutions and negative 2 revolutions. let's take a look at our answers. Number 15, what were your 3 coterminal angles? And let's start with Ethan.
495, negative 225, and negative 585.
Excellent job. 495 degrees, negative 225 degrees, and negative 585 degrees. Number 17, Jamie, what were your 3 coterminal angles?
Let me see, I had 630, 270, and negative 450.
Good. Of course, you want to put degree symbols on those so we don't lose points on quizzes and tests. But yeah, 270 degrees, 630 degrees, and then negative 450 degrees. Number 19, Quentin.
648, 288, negative 432.
Degrees is correct. Negative 432 degrees, 288 degrees, and 648 degrees. Number 21, Ethan.
135 degrees, 630 degrees, negative 585 degrees.
You're right about the negative 585 degrees, and you're right about the 135 degrees, but not the other answer you said.
495 degrees.
495 degrees should have been the other answer. How about number 23, Jamie?
300, I know, it's at the, okay. 15 degrees, negative 345 degrees, and negative 705 degrees.
Good. 15 degrees, negative 345 degrees, and negative 705 degrees. All right, let's take a look at number 25 now. And it says, well, go ahead and read the directions for us if you would, Ethan.
Draw a Cartesian line. Then plot each point and draw a line from the origin. Estimate the size of the smallest positive standard position angle terminal to the point. Estimate the size of the largest negative standard position angle terminal to the point. And level the initial and terminal side of each standard position angle and identify the quadrant of each angle.
All right, so graph paper out for this. Graph paper out for this. If you weren't using it before, let's do number 15 together. It gives us what point here? Ooh, this started to come off. That's not good. All right, we're all fine here. Nobody died. All right, let's try this again. So, Jamie, what point do they give us for number 25?
2 and 3.
2, 3. All right, so quick Cartesian plane. Again, we don't have to label everything necessarily, but draw a quick sketch of our Cartesian plane. Plot the point 2, 3. Obviously, class, this is going to fall in quadrant 1. And from this point, draw the line down to the origin to complete a positive angle and a negative angle. Obviously, the initial side is always right here at the positive x-axis. Obviously, this is the terminal side. So for sake of time, I'm not going to go ahead and label T and I for initial and terminal. What I want you to do is estimate how big you think this angle is. And then, based on this, subtract 360 to find out how big you think the negative angle is. So it's kind of guesswork, but educated guesswork. Guesswork, but educated guesswork. All right, what's your guess for the positive angle, Quentin? 60 degrees? What's your guess, Jamie?
50 degrees.
52 degrees. Ethan, what's your guess?
50 degrees.
50 degrees? All right, so Quentin, your negative angle was?
300 degrees.
Negative 300. Jamie, you had?
I did 50, so I had 310.
Oh, you did 50. I thought you said 52. 50. Okay, so we had 2 people guessing 50. So negative 310 degrees. You also had 310 degrees? Negative 310 degrees.
Or what?
The exact angle is 56 degrees.
Oh, I
Quentin.
wasn't guessing.
Quentin with the point on the first one. 56 degrees, and so negative 304. All right, number 27. Do the same thing. Draw your sketch. Put down your guess
27.
on number 27. So draw the angle, put down your guess, and let's see how close you got. So Quentin is at 1 point.
Oh, now we're counting points.
Oh yeah, oh yeah.
27.
27. Quentin with 1. Jamie and Ethan. We'll see who can get the closest. And maybe one day I'll teach you the secret to finding the exact answer.
Somehow.
We've got our guesses down. Quentin. No, we don't have our guesses down. Let's start with Jamie. Jamie, what was your guess on the angle?
120 degrees.
120 degrees. What was your negative angle?
Maybe 240 degrees.
So negative 240. All right. Quentin, what was your guess?
120 degrees. Or 115 degrees, I mean.
Okay, he's going to change it now. All right, because you don't want the same thing as Jamie. 115 degrees, so your negative angle?
Negative 245 degrees.
Negative 245 degrees. Okay, Ethan, your guess?
I'm still confused, kind of. What was this one?
Well, you got to give me a guess or you don't have any chance.
270.
270 degrees. All right, and therefore your guess would be negative, would have been negative 90. All right, so as we draw this, we're going to go to negative 2, positive 4, which should be up here.
Yeah.
Right? So we know it's going to be bigger than 90, but less than 180. So somewhere between 90 and 180. It looks like it's closer to the 90. So I think 120 is a good guess. It's actually 117 degrees, which means Quentin got it by 1 degree. He was 2 degrees off and Jamie was 3 degrees off, all right? So 117 and negative 243 for your negative angle. All right, number 29. We got 3, negative 5. 3, negative 5. See, some people just have an eye for angles. Ethan's got his guesses down. Jamie's got hers. Quentin has his. All right, Ethan, what is your guess?
400 degrees.
300. Okay, so your negative angle?
Next 60 degrees.
Negative 60. All right, Jamie?
What number did we do?
29.
Number 29.
I might have done the wrong one.
Oh, all right, so she stands no chance. All right, Quentin, what was your guess?
295 degrees.
295 degrees, and your negative angle?
Negative 65.
Negative 65 degrees. So the point was 3, negative 5. So we're going to go over 3, down 5 to right here. Okay, so that means our positive angle is going to be bigger than the 270, And if we look at the actual number, it is exactly 301 degrees. And so we have negative 59 degrees for our negative angle. So Ethan with the point there. All right, number 31. Number 31. Jamie's like, I was going to guess 301 too. I just didn't have a chance to do it. I got to do the right one. All right, guesses are in, and we're back to Quentin for our first guess. What'd you get?
210 degrees.
All right, so,
Negative 150.
all right, Ethan,
195 degrees.
and,
Negative 165.
all right, and Jamie?
200 degrees, negative 160.
All right, the point was -3, -1. Okay, so we're gonna go backward 3, downward just 1. And there's our line here. Obviously, it's going to be a little bit bigger than 180, but not too much. And it is actually 198 degrees, which puts it slightly closer to 200 than 195. Jamie comes in with the point, and of course our negative angle, negative 162. Got it by a point. So what Quentin did to Jamie a couple times ago, Jamie just did to Ethan. All right, number 33. This is a fun one. Number 33.
Oh, this is so dumb.
Well, just what is 3 halves?
3 halves.
1.5, right? 1.5. So that's not that bad. Quentin, you get first guess here. What you got?
50 degrees.
50 degrees, so.
Negative 13.
All right, Jamie?
55 degrees,
55 degrees.
negative 305.
All right.
60 degrees. Negative 300.
Is that actually what you wrote?
Yes.
All right. And the actual answer here, let's see, it's 3 halves 2. Okay, so that's going to be 1.5, and then up 2. You draw that line down. The angle is 58 degrees.
Yes!
So Ethan does to Jamie what Jamie just did to Ethan. So, negative 302 degrees is our negative
Almost
angle.
59 degrees.
All right, we got one last chance. So this is either Jamie forcing a 3-way tie, or Quentin or Ethan will win. And -1, negative square root of 3. If you want your calculator to get a decimal so you can get a better approximation, certainly feel free to do that.
Root of 3.
Fractions and radicals are not off limits. has his guess in. She's got her guess in. All right. Ethan, what's your guess?
240 degrees.
240 degrees, so negative 120. All right, Jamie?
I have 125.
125 degrees, so negative 235. Quentin? 210 degrees, so negative 150. All right. Let's see here. We've got negative 1, so backward 1. Backward square root of 3, which is about 1.7-ish. Okay? So there's our angle there. Now think about it. If this is 1, and if I were to draw this line and get a square root of 3, and this would be a 2, then this angle has to be 60. 180 and 60 is exactly 240. And Ethan wins the win. All right, so good job, Ethan, on that. Nice comeback win there at the end. Now, we will have competition on the homework as well, because you'll be doing 26 to 36 even as part of this, and we'll see who does the best in the homework. Before homework, page 35, numbers 14 to 36 to even. We'll take a look at that in our next lesson. Have a wonderful rest of your day, and you are dismissed.